You are hiking in the Florida Everglades and head southwest from your base camp for 1.72 kilometers. You reach a river that is too deep to cross, so you make a 120 degrees right turn and hike another 3.12 kilometers to a bridge. How far away are you from your base camp? The main concept involved in this problem is vector addition. The first step to solve this problem is to draw a picture of what's going on. You start at your base camp and you walk 1.72 kilometers southwest. So the angle between these two axes is going to be 45 degrees. You reach a river and you make a 120 degrees right-hand turn. After making the 120 degrees right-hand turn, you walk for an additional 3.12 kilometers until you reach this bridge. We now need to determine how far away we are once we reach this point from our base camp. That's equivalent to asking what is the magnitude of a vector that points from the origin to our current location here at the bridge. There are two possible ways to find this information. One way is to add these vectors, which I've called v1 and v2, and measure the magnitude of the resultant vector, or its length. The other way is to add these vectors v1 and v2 using their components, and then find the magnitude of the resultant vector from its own components. The approach we will use in this video is the second strategy, where we find the components of the vectors v1 and v2, and then add them together to get the components of the resultant vector, which I've called delta r. The next step is to find the components of the vectors v1 and v2 using trigonometry. We will start with the vector v1. We were told that this vector has a magnitude of 1.72 kilometers and is in the southwest direction. To figure out what angle that corresponds to, we measure the standard angle. So from here to here we have 90, plus another 90 degrees, plus the 45 degrees to get us to southwest. Knowing that the angle is 225 degrees, we can now use sine and cosine to find both the x and the y component. We take the magnitude of the vector, 1.72 kilometers, and multiply it accordingly by either cosine of 225 degrees or sine of 225 degrees to get the x and y components of the vector v1. To find the components of the vector v2, we first need to find its standard angle. To help us in doing this, we will take this vector and translate it so that it's at the origin, as shown in this picture here. In this picture, the angle lambda represents the standard angle of the vector v2. To find lambda, we will use the information we know about this angle theta, which is the standard angle of the vector v1, and what we know about this angle beta, which is the angle between vectors v1 and v2 when you make that turn, so it's 120 degrees. To find lambda, we take the value of theta, 225 degrees, and subtract from it beta, 120 degrees, which leaves us with a value of 105 degrees for the standard angle of the vector v2. At this point, all that's left to find the x and y components of the vector v2 is to take the magnitude of v2 and multiply it either by cosine to get the x component or sine to get the y component. So we take the magnitude, 3.12 kilometers, multiplied by cosine of lambda, which we found was 105 degrees, to get the x component, and to find the y component, we take the magnitude and multiply by sine of 105 degrees. To find the components of delta r, which again is the vector which points from the origin to where you currently are, we simply sum the corresponding components of the vectors v1 and v2. So, to find the x component of delta r, we take the x component of v1 and add to it the x component of v2 to get the x component of delta r. Similarly, to find the y component of delta r, we take the y component of the vector v1 and add to it the y component of the vector v2 to get the value of the y component for delta r. To finish the problem and find the magnitude of delta r, we use the Pythagorean theorem. This means that the square of the resultant vector is equal to the square of its x component plus the square of its y component. Solving for this delta r, we take the square root of both sides and plug in the numbers that we found here and solve to find that you are 2.71 kilometers from your starting point at the end of your hike.